let's talk about rational functions, in particular polynomial division. So remember that polynomials can be factored sometimes. Like if we take x squared plus 3x plus 2, we can write that as x plus 1 times x plus 2. So if we divide that by maybe like x plus 1, then that's like x plus 1, x plus 2 divided by x plus 1. So it just comes out to x plus 2. So polynomial, this is how polynomial division kind of works. But what about cases where we have like x squared plus 3x plus 3, and we want to divide that by x plus 1. Well, we can still kind of factor this. X plus 1, x plus 2, we just have a leftover of 1. So how we'd end up writing that is the result would be x plus 2 plus a remainder of 1, which we could write as x plus 2 plus 1 out of the thing we already divided by originally. So polynomial division is pretty much just going a whole bunch of methods for going from here to here. So the most intuitive method for polynomial division is, of course, to just factor the polynomial like we did up here, and then just cancel out whatever factor is in common. But we can't always do that. Like in here, how else would we know that x plus 1 is a factor? How would we know to factor it this way? Well, I guess we could complete the square in this case. But how do we take care of this in the general case? So we're going to introduce polynomial long division as a way to do that. Remember that long division, the method for long division is, if we do like 4 goes into 90, you always just, how many times does this go into the first number? Well, 2 times, and 2 times 4 is 8. So then you subtract 10. How many times does 4 go into 10? Again, 2. 2 times 4 is 8. Subtract 2, and then remainder 2. So you write 2 over 4. So then 90 divided by 4 is 22 and a half, simplifying 2/4 to 1/2. So for polynomials, this is pretty much the same process. You just got to keep track of more stuff as you go along. So let's just do x squared plus 3x plus 2 divided by x plus 1. We already know what the answer should be because this factors into x plus 1, x plus 2 as we saw before. So we already know that the answer should be x plus 2. So let's do polynomial division and see that we get this answer. So x plus 1 goes into x squared plus 3x plus 2. So first, you look at the leading coefficient of each term. How many times does x go into x squared? What do you have to multiply x by to get to x squared? Well, we've got to multiply by x. So we put in x up here. And what is x times x plus 1? Well, that is x squared plus x. Now we minus this whole thing. So x squared minus x squared, that cancels out. 3x minus x makes 2x. Now we do it again. How many times does x go into 2x? But we also bring down this 2. How many times does x go into 2x? Well, it goes in 2 times, so plus 2. And 2 times x plus 1 is 2x plus 2. When we minus that, it cancels, both of them. So remainder is 0. So that's our final answer, x plus 2. Great, cool. Now how about that one thing we did where we changed this to 3, and then this became plus 1 out of x plus 1 because there was a remainder of 1. Well, do x plus 1 goes into x squared plus 3x plus 3. So the first two steps are the same. X times x is x squared, so x squared plus x. Then you minus, cancel, and we got 2 x here plus 3, so x plus 2 because x times 2 is 2x here. 2x plus 1, cancel and we subtract, and then we get, should be 2. And then we get 1 left over. So that's where the 1 comes from, plus 1 over x plus 1. In another video, we'll do some more complicated examples.